Greetings, everyone. My name is James Furman. I currently serve as the U.S. Forest Service liaison for the Department of Defense, and really appreciate the opportunity today to speak with you regarding the DoD Wildland Fire Science Initiative. For those of you that I haven't met, a little bit of my background might be helpful. I actually served as the Wildland Fire Program Manager at Eglin Air Force Base from 1998 until 2012, and then for a year served as the chief of the Air Force Wildland Fire Center, as it was called at that time, prior to taking my current job with the U.S. Forest Service. So the DoD Wildland Fire Science Initiative, the topics I'll be covering today, we'll start out with some background and an overview of the current projects that are ongoing. Then we'll talk a little bit about co-production, which has really been fostered through the DoD Wildland Fire Science Initiative and has really become something important that DoD has elevated with regard to wildland fire science in particular. And we'll wrap up talking a little bit about the Integrated Research Management team, which I'm currently involved with, that helps to coordinate and facilitate the current suite of projects within the DoD Wildland Fire Science Initiative. So the DoD Wildland Fire Science Initiative is supported by the Department of Defense's environmental research programs. Those programs are CERDP and ESTCP. And CERDP is the Strategic Environmental Research Development Program, and ESTCP is the Environmental Security Technology Certification Program. So CERDP works more with fundamental science, and ESTCP has more to do with bringing forward tools that have mostly been developed through CERDP and bringing them forward into the management realm. And so what problems can we solve? That was the question that was asked by Kurt Preston, who manages the CERDP and ESTCP programs. And in the bullet list, you can see some of the focus areas for the Wildland Fire Science Initiative. Now, I'd be remiss if I didn't mention that any of these slides that you see that have tall timbers in the lower left-hand corner, I borrowed those, shall we say, from my friend and colleague Kevin Hires, who presented these particular slides at the CERDP ESTCP symposium back in early December. And for those of you that don't know Kevin, a little of his background may also be helpful. Kevin and I worked closely together, both of us on the staff at Eglin Air Force Base when I was the program manager there, and he managed the prescribed fire program and ecological monitoring programs, and really, he helped bring science to the wildland fire program there at Eglin Air Force Base. When I took the job at the Air Force Wildland Fire Center, he stepped up and managed the overall program at Eglin. When I took the job with U.S. Forest Service, Kevin served for a year as the interim chief for the Air Force Wildland Fire Center. So we've worked closely together for years and continue to in my current role. So again, I've borrowed a few of his slides here, kind of skimming the cream off of some of what he covered in the symposium. So looking at the investment that CERDP and ESTCP have made in the DoD Wildland Fire Science Initiative, particularly just in 2019 and 2020, CERDP has funded $23 million in research for DoD fire science need. linking fuels, energy flux to ecological variation, understanding fire line interactions, looking at fire and atmospheric feedbacks, also looking at what we're calling marginal fire, fire behavior and smoke consequences when you're burning with low intensity fires, as is typical with prescribed burning. And we'll talk more about that later in the presentation, why that's important and how it's different than most of the research that's been going on in wildland fire over the years, and developing the fluid dynamics of fire effects. And we'll dig a little more deeply into that as well. So I'm not going to read this entire slide, but this is just a quick overview of projects that are currently funded. And if you read through them, you'll see a general theme, and that has to do with these new physics-based fire models. And we'll talk some more about those. The physics-based fire models just show tremendous promise for I guess upping the game or providing improved tools for fire managers, really with regard to prescribed fire and wildfire. So DoD is really focused on funding projects that are helping to refine these physics-based fire models. More of the projects that are currently funded. You can see a wide range of different entities that are managing these projects. But again, you see the physics-based fire models throughout, and at the very bottom you'll notice this kind of one outlier, which is the Integrated Research Management Team, and that's an ESTCP project. All the rest of these are CERTIP projects, but it's an ESTCP project that we'll be talking a little bit more about later in the presentation. So I'd like to thank Colin Hardy, who works with CERTIP ESTCP. He's recently retired from managing the U.S. Forest Service Rocky Mountain Research Program. And he's provided these last few slides where he did a breakdown, and these 11 projects are the FY19 and 20, and just showing the affiliation, who is managing as principal investigator for these 11 different projects that are currently funded. So as far as the participants, all the different entities that are involved in these projects, a much more extensive list, looking at 31 different participants in the project, including international participants from France, the UK, Scotland, Spain, as well as a wide range of educational institutions, etc. So breaking down those affiliations a little further, a pie chart showing mostly academic institutions in the U.S. as far as involvement goes, but also wide involvement with federal, and then you also see those 4 international affiliations. Now, that's some background information, and I want to talk a little bit about co-production and also about the concept of prescribed fire science. Now, co-production we'll talk a little bit more about in the coming slides, but this is the one slide I have on prescribed fire science, and again, thank Kevin Hires for that. If you think about federal land ownership patterns, particularly with U.S. Forest Service and Department of Interior agencies, where most of the land is, and as you would expect, most of the research in fire has been done to address problems. It's all in the western United States, or certainly not all, but a very large percentage is west of the Mississippi River, and for good reason. Most of the research has been focused on wildfire. What does it take to generate crown fire? Looking at models to help people that are managing destructive wildfires in those western fuel types. But DoD has extensive and some of the largest in the country prescribed fire programs, not only in the southeast at Eglin, Fort Stewart, Fort Bragg, Fort Benning, Avon Park, some large programs at all of those, but in the western U.S. as well. Fort Carson in Colorado, Joint Base Lewis McChord in Washington, and the list goes on. So Department of Defense has some real interest in prescribed fire and providing tools to prescribed fire practitioners. And these DoD funded research projects really focus in on helping to build and provide tools for prescribed fire, to the point that we really feel like there's a new branch within wildland fire science that we're calling prescribed fire science. Actually have published a paper. You can see on the right hand side of the slide, that's just a copy paste information about the paper that's been published. And if you look at the list of people involved with publishing this paper, it is many, almost every one of them, all but maybe two, are directly involved in the DoD Wildland Fire Science Initiative, these projects that have been funded by CERDIC and ESTCP. So the quote at the bottom, until now, there has been no organized leadership for advancing prescribed fire science. And at this point, really, DoD is providing organized leadership for prescribed fire science. So I just think that's really noteworthy. That's an important contribution that DoD is making to fire science. So let's talk a little bit more about co-production. It's something of a buzzword these days, but what exactly is it? So I've put together what I'm calling the interaction pyramid as related to co-production. And at the base of that pyramid, we have the cohesive strategy, the wildland fire cohesive strategy. And very broad, but essentially it says science is good, use it for managing fire when and where you can. Now, supported by the cohesive strategy, you have the next layer, which is collaboration. And collaboration is fantastic. That's actually when scientists and managers are bumping elbows and talking to each other, working together on prescribed fires. Things like the RX cadre experiments back in 2011 to 2012 at Eglin Air Force Base and other locations in the Southeast are great examples of collaboration. So above collaboration, the next step, or the peak of the pyramid, is where co-production falls. And co-production is where the manager is directly involved in all phases of research. They are right there, essentially attached at the hip with the research scientist, helping to steer research in a way that assures that it, in the end, is management relevant. So that's where co-production is separate from collaboration. Collaboration is fantastic. Everybody's working together. Co-production is where an actual manager is directly involved in development and management of research programs. I'd like to thank Colin Hardy for this great slide that outlines the research to action continuum. On the left-hand side, you have pure research, essentially research scientists doing what research scientists do, getting down into fundamental research. On the far right-hand side, it shows where actions are being done in the field, planners and fire managers actually getting fire on the ground. Here in the middle, in these purple areas, application development, analysts and modelers, where you've really got fertile ground for co-production to take root and make a difference. I mentioned the RX cadre experiments at Eglin Air Force Base in 2011 and 2012 earlier in the presentation. And just wanted to touch base a little more on that, as they really were important in helping to set the stage for the level of co-production that came later. There's great collaboration. A lot of the relationships were built with many of the same scientists that are now working on the projects with the DoD Wildland Fire Science Initiative. So relationships were built, lessons were learned, and a lot of good work was done. So in a more recent example, the burning that was done at Tyndall Air Force Base to reduce the fuels from Hurricane Michael, which hit in October of 18. Title says collaborative burning, but I would make the case that this was true co-production, as the fire managers not only at Tyndall and Eglin were involved, but also the Florida Forest Service, the U.S. Forest Service, Longleaf Alliance, a number of different management organizations were directly involved in setting up and measuring the effects of the burn and the smoke plume, etc., from these burns at Tyndall Air Force Base. And for those in the audience that have not seen what a strong Category 4 or 5 hurricane can do, the picture in the lower left gives a good example of what used to be a standing mature pine forest. So you can imagine the fuel loadings are just through the roof, and figuring out how to reduce those is a really important management concern. And can you do it safely? I'd like to talk now a little bit about an ESTCP project that I was fortunate enough to serve as principal investigator for. I worked directly with Rod Lynn, the developer of the FireTech physics-based fire behavior model. He works out of Los Alamos National Lab. Also involved Kevin Hires at Tall Timber, Brett Williams, the Wildland Fire Program Manager at Eglin Air Force Base currently, and others. And this was the next generation fire modeling for advanced wildland fire training. And for those of you that were at last year's NMFWA conference, there was a presentation given on this particular project. I was supposed to give it, but could not make it because of COVID. So Andy Beavers actually stepped in. Thanks, Andy, for covering that for me. But this really gives an idea of the power of the visualization tools generated by these physics-based models. Here we modeled 5-line ATV ignition and longleaf pine fuels at Eglin Air Force Base. You can see the display on the right showing the interactions between the different flaming fronts. But I've really gotten a lot of I'll just say mileage out of this project. It's kind of taken on a life of its own as far as level of interest and that sort of thing. And the bulleted list here just goes through some of what has been accomplished through the project. A number of presentations. Actually, you got called to present to the Joint Fire Science Program as they're moving towards more co-production with the limited funds that are there. So presented this project as a case study, had managers workshops at Eglin, Fort Stewart, and Tall Timbers, International Association of Wildland Fire Fuels Conference, a number of presentations. here, I do want to touch on the final bullet, which was perhaps the most important thing that came from this project. And I will say this is one of a number of really great visualizations for different types of fire behavior from different firing techniques generated from this project. But the Interagency Prescribed Fire Training Center, which was located in Tallahassee, Florida, and is now actually co-located at Tall Timbers Research Station, there north of Tallahassee. They actually adopted a number of the simulations, these visualizations from this project, into their curriculum, which is shared with prescribed burners in training from around the country, and they even have international students that come through. And this project was classic co-production. I mean, myself, Kevin Hires, Brett Williams, and Rod Lynn literally sat at a table there at the Natural Resources Office at Eglin Air Force Base and designed this project so that it would meet the needs of Rod Lynn as far as really putting the model to the test, but we designed it specifically to get at addressing questions that we as managers had in order to get visualizations that could be used for training tools. So it's really a successful program. There have been additional ripple effects that have come from this even since then. One fairly recent ripple effect from this project was that I was asked to present a 5-minute lightning talk on how artificial intelligence could be used to enhance wildland fire science. This was called the Wi-Fi Commons Workshop, sponsored by the National Science Foundation. So on the right-hand side here is the actual slide that I presented. It was a one-slide presentation where I said we could use artificial intelligence to explore, develop, and refine managers' rules of thumbs and trigger points. So using existing data, and I will say that the ESTCP FireTech project that I talked about in the previous slide produced a very rich data set for all these different scenarios that we tested. So I said, let's use AI to take this existing data set and really just dig into it, hypothesize, explore, develop algorithms for prescribed fire behavior and smoke transport as related to different ignition patterns, wind speeds, fuel characteristics, and burn sizes that we explored in that project. And using AI, determine where the data gaps are. Are there inconsistencies or data gaps? And also mention generating practitioner references. Most wildland fire folks, at least if they've been through S390, have seen these what's called hall charts that you can see in the lower right-hand side, and use AI by mining data from this project to generate some hall charts that have to do with different prescribed fire scenarios. And most importantly, that last loop, maintaining communications with managers to focus on the most pressing questions to keep it relevant. So was really excited to be invited to that and thinking about the potential positive impacts that could come from that co-produced project. So taking the idea of visualizations and training tools from these physics-based models a step further, one of the current CERTIP projects is actually exploring using the data sets from that original project that I was involved with, as well as gathering additional data for inputs into developing virtual reality training for prescribed fire practitioners, where the person being trained would actually put on the virtual reality headset and would be able to see in 3D as if they're standing, in or next to the fire, and would be able to see the differences in fire intensity based on whatever firing patterns they requested. So in the early stages of developing this, but just could be really, really powerful. And notice that Tall Timbers Research Station is involved in this project as well, and the uh, Interagency Prescribed Fire Training Center is located at Tall Timbers now. So a lot of synergies to be gained there. And again, this is all DoD funded wildland fire research. And so just really, really excited about where this is headed. The final thing that I would like to cover in this talk is my work with the Integrated Research Management Team supporting the DoD Wildland Fire Science Initiative. So the overarching objective for this project is to develop an integrated system to maximize collaboration, personnel safety, probability of success, and overall positive impact of the CERDP DoD Wildland Fire Science Initiative, while providing proof of concept for an integrated research management team as a national model via successful establishment and implementation. So some would say that this is the part of my job where I herd scientist, and that's not too far from the truth, but what I do is I serve as something of a liaison between this group of scientific researchers and the host agencies or land holdings where these collaborative research burns are going to be carried out. So we'll talk a little bit more about that in the coming slides. The Integrated Research Management Team is based on the concepts of the Incident Command System, or ICS. It provides a single point of contact and organizational structure to CERDP and to the host units in order to coordinate and enhance synthesis of the DoD Wildland Fire Science Initiative projects. The structure is adaptable based on complexity and local requirements. In the diagram on the right, you can see the planned organizational structure for upcoming burns at Fort Stewart, Georgia. The large blue oval in the center represents the Integrated Research Management Team, showing key personnel and their functions. The smaller blue oval to the lower left shows the project principal investigators and points of contact who are under the direct authority and management of the IRMT. IRMT, in turn, is under direct authority from CERDP and ESTCP. The dashed lines show coordination, which occurs not only between the different functions within the IRMT, but also between the IRMT and the host agency. This 4-year project was funded in spring of 2020. The first collaborative research burns are scheduled for early in 2021, and research is ongoing. One of many services provided by the IRMT is coordination of airspace. Particularly on these research projects, you have multiple aircraft, including UAS, flying simultaneously in DoD airspace. So very complex airspace management has to occur months in advance. All of this is managed by the IRMT, getting information on requirements from all the different research projects involved, not only from the DoD Wildland Fire Science Initiative, but also through other research projects that are piggybacking on these highly instrumented research burns, including FASME, or the Fire and Smoke Modeling Evaluation Experiment. The IRMT provides big picture products and guidance to the principal investigators and to CERDP to facilitate inter-project collaboration, data sharing, and safety. The diagram on the right shows 12 current CERDP wildland fire projects that are being coordinated and managed through the Integrated Research Management Team. You can see the interconnections between the principal investigators, co-PIs, and collaborators. Obviously, many connections between these projects with shared resources. So the IRMT documents these project interconnections as shown in the diagram, also determine data requirements and synergies between projects. We do this through a number of ways, including monthly Zoom meetings. We have a shared filing system online that all the project personnel have access to, and the IRMT develops and posts the planned burn locations, timelines, those sorts of things all online, and shares those in the monthly meetings. The responsibilities of the IRMT can really be broken out into 3 phases. The pre-burn planning and coordination, which is what we've been busy with ever since the funding dropped, just making those connections with the host organizations, figuring out airspace, figuring out what the requirements are for the different projects that are out there. Can they share a UAS platform? Those kinds of things. Then phase 2 is the actual implementation of the research burns. That's when everyone converges on, whatever location it happens to be, and you have the logistics of traffic plans and airspace and porta potties and whatever else needs to be done. Then the final phase is synthesis and manager feedback. And you can see the diagram on the right, which is probably common to most people in natural resources. It's essentially the adaptive management loop, which is the way that the IRMT functions as far as using everything as a learning experience, incorporating lessons learned as we go. Part of the synthesis and manager feedback will actually have questionnaires and standardized AARs, and everything is documented. And so besides the final report from this project, one of the other things that will be generated is a guide to establishment and use of the IRMT for these large related research projects, kind of when it might be appropriate, when it can be useful, lessons learned, that sort of thing. So just a little bit more about the project. You can see the project team on the right and the research burns that are planned. We may have the tall timbers burn done by the time this presentation is given. It depends. Also depends on travel restrictions, but planning October 2021 to go to the Sican Marsh Preserve, which is a TNC preserve in Oregon, then planning Fort Stewart for the first week of March in 2022, and then Eglin Air Force Base in March 2023, and 3 more to be determined. There will be a total of at least 7 burns that the IRMT will be involved with. I might just mention that the research that's being done on fluid dynamics and energy release and that sort of thing, as far as DoD gathering this kind of information, it can be used for things other than just prescribed burning. These physics-based models can also do things like model thermonuclear reactions and those sorts of things. And in the lower left, this is just another picture of the post-hurricane burn that was done at Tyndall Air Force Base. So that concludes the presentation. I look forward to hearing any burning questions that you may have in the panel discussion. I've also included my contact information in the slide here so that outside of the conference, I would encourage you to give me a call if you've got any questions about what the U.S. Forest Service might be able to do to help at your installation. Please feel free to give me a call. I am at your service. Thank you. Bye.